Thanks everybody for joining. This is the January 2023 user meeting, and tonight we have Allard, who is the founder of Axon IQ, and he's going to tell us all about domain-driven design, microservices, and all sorts of really neat concepts that we probably don't do enough of. And a big thank you to our sponsors, Improving, who's providing the virtual hosting and the meeting space, the physical meeting space as well, and also pizza. So and we're also hiring. It's a great place to work. I absolutely love it here. And we're using event-driven microservices right now in the project that I'm working on as well. So I would love to learn more. This is absolutely timely for me personally. So thank you so much, Allard. I really appreciate it. And please, without further ado, take it away.
All right, thank you. So are you still in the fairy tale when using event-driven microservices, or are you realizing that there's a lot of evil witches and nasty things?
So far, so good. So
oh, you're not there yet. Okay. You'll meet the ogres and the witches later.
Okay. Right. At least I'll know to carry some ogre candy and feed them. So
better come prepared. All right. So when we talk about fairy tales, of course, we need to start with well, you have to start it off right? So once upon a time, and for some of you that might have been years ago, maybe yesterday or tomorrow. Yes. Who knows? Anyway, once upon a time, we built software this way. So there's this, as Ted Neward called it, the universal BBC architecture, which has nothing to do with the British Broadcasting Company, but instead is there to design beautiful systems. So the most important asset that we have in any organization is the data. And we store the data comfortably in a cylinder. Now we don't want people poking that cylinder directly, right? So we put a box in front of that, and that box will hold business logic so that we safeguard the data from us humans messing around with it and making mistakes. But that data also needs to be presented. So what we do is we put another box in front of that to host our presentation logic, right? And that's what we put in there. And it's very important that these boxes do not touch. And these boxes only communicate that way, right? And you don't want that box to communicate with the cylinder, because then things explode and things go really bad. It's a very naughty thing to do. Some of you might recognize this as delayered architecture. It's still the dominant architectural style in a lot of applications, and which is unfortunate, but it was designed to solve the problems that we had in the 70s. Yet we use it still to solve the problems today.
50 years later.
50 years later, because frankly, we don't know better. Okay, there's still hope, right? I'm slightly exaggerating, and I'm using the term we, by the way, in the most collective way possible. It's mostly them, not so much us, right? But okay, let's not divide too much. Unfortunately, most of that software that was designed that way turns into what in domain-driven design is called a big ball of mud. As you can see, it's not really mud. And you can still see the architect sitting on top of it. And the architect's really proud of its creation, right? It built something beautiful. Actually, well, no, never mind. I'm not going to do it. You should. I wanted to find a picture of a dancing dung beetle, and ended up on a TEDx presentation about dung beetles, and they actually dance. Anyway.
This is what we spend our time working.
This is working hours, right? That's fine. But this architect right there doesn't realize what it has created. For it is the perfect thing, right? But it's full of code smells, as you can imagine. Mm-hmm. And the problem of the big ball of mud, or the pattern, and that's how you can recognize a piece of software being stuff, is the fact that you can only really make changes to it by putting more mud on the outside. So if you find yourself working on a software system and are not comfortable changing what happens inside, but are just on the outsides, changing a little bit of APIs, calling existing APIs only, but not changing anything inside, that's when you're in a big ball of mud. And that's problematic. We were talking about monoliths earlier and people not really appreciating legacy software the way it should be. That's because a lot of legacy software simply stinks. So we have around 2014, we have microservices to the rescue, right? Microservices are our knight in shining armor. They're going to rescue us, and we'll be live happily ever after. So what we do is we take the box cylinder and we divide it into small parts, right? And we make every part responsible of a specific portion of our big system, so that we can understand every small portion, and we don't need to understand the whole thing, right? And then we can replace these components, and they're fun and they're really cool because we get to use all sorts of cool technology as well. Now, a couple of, I think 2 years ago, I read a colleague pointed me to a paper, which I then started reading, from a company whose name I'm not going to mention in this context because I'm not particularly positive about that paper. But it suggested the idea to organize your services into different categories. So you would have some services that are responsible, you call them entity services, and they're responsible for storing the state of your system. They would store specific concepts like the customer data and the inventory data and all that kind of stuff. And then you would have services that provide business services on top of that information, but which are then reusable by other business units, and etc. And then you would have another category of services that are your BFFs, like for front end. Does that sound familiar? That's box cylinder all over again. So now we have two layers of box cylinder in and on top of each other.
Microservices done wrong.
Beautiful, and there's a lot of this going on there. But so the problematic thing here is that we have taken the practices that give us the big ball of mud, and we've increased the number of deployment units. What do you get? I can see trouble. Trouble. A big pile of mud.
But they're not independently deployable necessarily.
Well, they are, of course. You can
But
deploy each one. You'll break the entire system if you do, but you can't, right? I mean, no problem until you do. But so what we should be focusing on instead is increasing the modularity. Okay, where have we heard that before? Probably since the same 70s that we were talking about earlier. But so modularity in PowerPoint is really simple. You use bright colors and you make sure that there are no lines between all of the components, and then you're done. And if you draw a box around all of them, you have a monolith. So it's really that easy. But the idea, of course, in practice, it'll be a little bit harder, but we'll talk about some ways to achieve that. But we have the beautiful monolith, and this is where legacy software survives, right? There's actually some legacy software that uses really boring technology, but actually supports big businesses. And they're over there. And now we can increase the number of deployment units, and then we have real microservices, the ones that are independently deployable. And that's where we all want to be, right? Fortunately, that's where we are. And the reason for that, it is very easy to end down there because there's evil anti-modularity forces at play. This is our evil witch in the fairy tale. But those forces grow stronger as you go further to the right. So just imagine a refactoring task. If you do that in a monolith, you'll have your code base, you'll go to a word that you don't like, you do rename, you change the word, and all over the code base, it changed. You compile, test, deploy, done. Next story, move on, right? Usually not quite like that, but now let's imagine we've got microservices. You do your rename, you rename your service. Wait, it has an API. API calls. We're going to break the other services. Which ones? I don't know. So we need to be backwards and forwards compatible. We need to take that into account. So we have to deploy everything at least twice to move from A to B, and one by one, starting at the last one, and then moving your way up through that beautiful box cylinder in and around itself. So that simple task that was so easy to do in the monolith becomes really difficult to do in microservices. And while they take different shapes and forms, there's also people in suits that tend to be evil anti-modularity forces because they tell you that there's a deadline. And oh yeah, the scope shifted. So why does scope never? That needs to be in the within the same deadline, right? Or oh, instead of next week, it's this week. And oh, by the way, there's extra stuff that needs to go into this release. So you take shortcuts. And when you take a shortcut, you say, okay, to do, fix this on Monday. And then it's some Monday 5 years later, and you realize, which Monday was that? Well, never mind. If we haven't changed it by now, it's probably not important. You removed it to do, and the code stays the way it was. So, okay, that night in Shining Armor was slayed by the dragon, unfortunately. But now we have events to the rescue, right? There's events we can use. There's this really beautiful concept of events that must solve all of the problems that we have, right? And the idea is quite simple. If you have two services and service B needs to do something as a result of an action of service A, you just call service B after whatever action happened in service A, right? But the problem is when services C and D now also need to be notified, you need to change the logic in service A to accommodate the calls to service B and D, C and D. Which is annoying because now you need to change existing components just to change the behavior of new components that are added. So your scope of change becomes bigger. So we use events for that, right? We use a magical tool where you throw events at it, and then other components just watch that space and events magically appear, and then problem solved. But now we can add new components, and then nobody cares because service A doesn't need to be changed.
Hooray.
Hooray, right? What could possibly go wrong?
Oh, sure.
So we have gotten ourselves a universal event-driven microservices architecture. Mind you, entity services, business logic services, BFF, right? Because that's the best practice. Slightly exaggerating, being sarcastic here, but this is what I've unfortunately seen people truly believe, which was quite, never mind, let's not use those words. So a little recap. So we used to do box cylinder, but that gave us a big ball of mud. So we started doing microservices, but that gives us a big pile of mud. So now we do whatever, however that's different, hoping we get rainbows and unicorns. And my daughter made me do that. She was actually amazed that I promised her, no, I'm traveling the world and showing your rainbow and unicorn to people all over. Really? Yeah, unfortunately. This is a little summary of what we've been trying to do with a lot with microservices. Right? Again, we is not us, but them. So the definition that you could come up with for an event is magical pixie dust produced by unicorns used by software developers to make their products scale, perform, and do exactly what the product owner intended, which of course is not true. But the other, a little bit more realistic use of the word is anything that resembles asynchronous communication. That's how it's being used a lot in practice. Oh, just use events. Well, what do you mean? Well, you call that service using an event. Ooh, that's already a wrong way to get started, but we'll talk about that a little bit more. The thing that we are doing collectively is we're painting each other beautiful pictures. This is, oh, it will be awesome. Look, I mean, it's pretty good. But we always forget about those little annoying details. Yeah. And there's lots of them. And they can make your life really, really miserable if you don't come prepared. And they will even make it miserable when you do come prepared, but that's actually mosquitoes. But we need to come prepared when we want to start with those microservices, right? And even microservices has plenty of its own mosquitoes around. So the thing is that our journey towards microservices is wrong. So when we have an idea for a mechanism that provides a solution, instead of trying to go straight for microservices, because that road is dangerous and you'll probably digress and end up not where you want it to be. We want to take a road where we start off with a monolith because it is cheaper to refactor. It is cheaper to make changes within that monolith. And one of the problems we have when we build software is we don't really know what we need to build. Right? This afternoon, I was doing the lunch edition of this talk.
Thank you.
Bank.
Thank you, by the way.
No worries, welcome. At JP Morgan. And well, there was a simple question. Who at JP Morgan knows everything that happens at JP Morgan? That person doesn't exist, right? Nobody knows everything. So when we do a project, whatever you want to call the person, whatever the title is, they don't know everything. We need to discover everything ourselves, what we need to build, right? So you can have big books with specifications. They're not going to be complete. They're going to be wrong, and we don't know where. So there's a lot of discovery that we need to do and a lot of finding out of what it is that we actually need to build. So while we are learning, we need to make sure that the mistakes we've made, not because we're stupid, but because we just didn't know and we're learning on the job, we need to be able to refactor those cheaply. So we want to stay there first. And we want to find the actual boundaries of those little diagrams, right? We need to be able to move things around and make sure we find the right boundaries of our modules. And as we find those boundaries, we have the opportunity to extract them and say, okay, this is a nice component. We could have a different team work on that. Let's take that boundary. We can now scale it differently. Or maybe instead of having another team, maybe that blue component is really uses a lot of memory and it just steals all the memory of the other components. So you want to give that its own little JVM, this little box of memory to use, whatever it is. There could be all sorts of reasons to do that. By the way, they're always non-functional. There's never a functional reason to split something into microservices. Right? And then when we have that, we can extract some more and start scaling, et cetera, as we've learned. Of course, the big question is how? How are we going to go in that direction and not end up in the same big ball of mud, which is the center of gravity, right? Everything in the end will end up there. And domain-driven design is a very interesting and powerful concept in this regard. And that's particularly interesting because domain-driven design was conceived well before microservices. But when microservices came out, domain-driven design won in popularity quite a bit because there's a lot of concepts in there that are important, I would say, in microservices. I would actually dare to say if you do microservices and don't know about domain-driven design, red flag. You might be accidentally doing it, that's fine, but it's still a flag nonetheless. Who is not familiar with domain-driven design? If you don't make noise and raise your hand, you won't be on camera. Everybody is? All familiar? All read the blue book?
Haven't read the blue book.
No?
No.
Any blue book survivors here? Congrats. You should have badges for that. You should have these.
About an inch thick, or inch and a half thick or so.
Yeah.
Yeah.
Yeah, the kind of book where, so there's two reasons why you don't want to read that book it's not a nighttime reading kind of stuff, right? It's really dense.
It's a text.
So you get a brain overload when you read it. And second is when you drop it, because you fall asleep, you probably won't wake up. It's thick as in actual weight, but also as in how it's written. It's a textbook. It's very, but the concepts are very valuable. Unfortunately, there's other books that are a little bit lighter and easier to understand. But the idea of domain-driven design is there's a domain, and the domain is the world around us. Okay, this is literally the world, but it is the environment in which you build your software. And in that environment, there's all sorts of rules, regulations, there's habits, there's people using specific language, things that we've always done like that, but nobody knows really why. Right? All of those factors play a role, the world around us. And in that context, in that world, we use models to make certain tasks easier to do. We have a specific problem we want to solve. So we create a model that selects certain aspects that are in that world that are relevant. And we use those aspects to then solve our problems. And we end up with a model like this, which may look somewhat familiar to you. Actually, in Europe, it does not look familiar at all, this map. Strange enough, I don't know why. Does anyone know what problem this is designed to solve? Because we're using this to solve the problem of kids not knowing what the world looks like. And we teach them this, which is quite horrible, because we teach them that Greenland is massive. And there's a lot of snow. So if the ice caps melt, nobody cares because there's so much of it. Which may not be the entire truth. And it's certainly not bigger than the US, right? It's actually significantly smaller. Canada is like twice the US. Is it? I don't think so. So, but what is the, so it's not landmass, obviously. We're not solving the landmass problem here, but does anyone know?
Sailing, maritime,
Navigation.
yes.
I was going to say, does anyone have a book? But so if you do have a book, you can drop it in the water at some place. Then you pick your destination there. Right, Hank? That's where we're going to go. And then you can draw a line, and the angle of the line tells you the direction in which you need to sail. And the number of squares, mind you, they're all squares. There's no rectangles on the map. The squares that you cross, they tell you the distance. So actually, this is the same distance. That is the same distance as that. So it was designed to solve that particular problem. And it's actually pretty elegant if you think of it, that you can do that with the map, right? There's a similar map that can do the same on land. And if you look at it, it will look weird, which is really our problem, because that is also how we look at software. We use a model, and I haven't seen one here yet, but maybe when I get a tour of the offices.
Sure, yeah.
No, but I love to see domain models on the map, especially when they're behind the desk of an architect. Because sometimes they tend to create the canonical domain model of this. This is what this company does. And then they love to tell project teams that, no, that's your model. I created that. I'm the dung beetle. It doesn't work because that model cannot possibly solve all of the problems that a business has, right? So they're trying to teach children using that model what countries look like. That's just plain wrong. So here's another model. This is a map of ancient China. And the part with the white background is the rest of the world. So apparently in ancient China, what happened in the rest of the world was not the primary focus. Well, if you build a wall that you can see from the moon, I can imagine you don't care much about what happens on the other side of that wall. You're going to keep it there, right? It's about internal stuff. So it says something about the culture at that time, right? They're not about sailing, but they're about what happens inside. Is that map more useful than the other one? No. I mean, if you want to teach people what was important in China, in ancient China, using the other map that we just saw, it's completely useless. If you want to use this map to navigate the oceans, good luck. So the maps serve a purpose, and it's about the purpose. Right? And that's something we forget when we build
Context too.
Absolutely, very important. So domain-driven design gives all sorts of measures, means, and tools to deal with that. And some of those are tactical. We have some modeling practices. There's a lot of, in the book, they talk a lot about supple design. But there's certain building blocks that we can use. So an entity and a specific behavior, and value objects has other behavior, and the repository have a specific role in the model. So it gives you some tools to play around with. And that's useful because it allows you to build a common language with your colleagues. It's nice if you say something that they actually understand what you mean. And especially relevant in microservices are the strategic patterns. Like no piece of software is completely isolated from the rest. it somehow integrates with something else, right? Your restaurant experience actually is integrated with your Uber experience. And it integrates through you, the fact that you get a Uber to a restaurant. So even some computer systems are not integrated technically, but they're integrated because humans read something on one screen and then type something on the other, which is one of the context mapping, which is not there. It's called separate ways, which is technically really easy to implement. You just don't do anything. But the concept of context mapping is, so how do these things work together, and making that explicit is actually quite useful. So all those things that we can do in domain-driven design, or domain-driven design helps us to do, gives structure to a model. It allows us to paint these little components in bright colors and decide which lines we want to draw as not regular lines, which are dotted lines, so that we have modularity, right? That's what I said earlier. That's how to do modularity in PowerPoint. So that's a nice way to get you started, right? To go to the first step. But then how do you do that? How are we going to make sure that whatever we build, we don't get stuck in microservices? So there's a lot of, well, debate is maybe not the right word, but you can read blog posts about how to do microservices, and some people say you should go straight to microservices, because if you don't, you get stuck with one big ball of mud that we will never be able to change again. Others say, no, you want to start with a monolith and then slowly evolve. Hey, that sounds familiar. But there's some truth to both. First, you want to build a monolith, but you want to build that monolith, not the big ball of mud. So to be able to move on from there, there's some interesting aspects in reactive systems, not so much reactive programming, but reactive systems. And you might have heard of the Reactive Manifesto. You might have actually signed it digitally at some point, which I did. I don't know why, but there's a new version of that, which is called the Reactive Principles, and there's a website for it. And you can actually read that. I recommend you do. I actually spent time writing some of the parts, so it's nice if some people actually read it. But one of the aspects there, and the most important one, is we want to build software that is maintainable, extensible, and responsive, right? Of course, when we click something, it needs to do something, and when we want it to change, we can just make it different if we want. And then if we need to perform maintenance on it, it has to be maintainable. I mean, it's not that difficult, right? We just want it all. It's very simple. So how do we achieve that? Well, the software has to be resilient, so it can deal with errors properly, and it has to be elastic, so that when the use scales, either up or down, you can scale the software with it. And to be able to achieve that, it has to be message driven. And message driven is not necessarily does not necessarily mean a messaging system, but if you go to the original OO descriptions, they're about objects and they send each other messages. We call them method calls.
Small talk. They call it message, sending messages.
It was much more explicit.
Yeah.
Than what we do now. But a method invocation, you can see that as a message, right? But we do want to take it a little bit further. So that message driven is really important. Unfortunately, most will say, I know messages. It was the magical pixie dust, right? Remember events? So they think about events, but events are one way to communicate between, this one way components could use to communicate with each other. But we actually found there's 3 reasons why a component would want to talk to any other components. And one of them is to notify the other component that something happened, right? Which is what you could use an event for. Hey, I noticed that, or I did something, I'm just telling you. Another reason is that maybe this component wants the other component to do something. I need you to prepare a payment. I need you to ship this package to somebody. I need you to do something. And that something will probably, when actually executed, change the state of the system. And the third one is the component has a need for information because it needs to make a decision, but doesn't have the information required to make that decision. Or there's just a user that wants to see some information on screen. So we ask the other component for information that we require. And the interesting thing is, if you consider those as messages, you will want to route them differently. They follow different routing patterns, right? So events are very much pops up. We speak of something in the past. So to be honest, I don't care about your opinion. I'll just broadcast it to you. You could do whatever you want with that information. It's a fact. Things in the past, as far as I know, we haven't found a way to go back yet to fix them. So they happened. There's nothing we can do about it. Commands, on the other hand, you typically have a single component. Even if you have 4 candidates, you'll pick one, and that one becomes responsible for changing or doing the actual thing that you ask. You don't want 2 components to start doing the same thing. So here's a package, send it. Suddenly there's 2 packages going to the destination. That's not what we want. So we pick one. And in queries, we actually found several patterns, but the most common one is what we call point-to-point. You just have one requester, and you ask a component for specific information, it gives you the answer. But sometimes in systems, you don't have a single authoritative answer to a question. Sometimes you just have a question, and then you can get different opinions. Like, what's the price of a hotel room? Never the same, right? Depending on which ways you find, you always get different pricing. Try buying airline tickets, it's worse. So what you want to do is gather. Now, there's whole websites that do that for you, that give you the cheapest, which is very Dutch compatible. But what you do is you send out a question, and any component can provide you an answer, and then you do your reduction function to find the cheapest hotel, or the shortest flight, or the whatever it is that you want. And the third one is what we call subscription query, is a query where you basically say, keep me up to date on the status of this. And then you get the answer of what it currently is, and as soon as that changes, you get an update. Give me the latest news. Okay, here's the last 10 items. Oh wait, breaking news. Here's some new item. Right. So that is a question where the response basically stays open, and you get more answers as they come in, which is really powerful when you want to build real-time UIs for it. So messages are not the same thing as events, right? Events are messages. Make sure I say that right. But not every message is an event. And what this gives us is the concept of location transparency, which in networking is a very common concept. Like if you enter a URL in your browser, you don't know where that request goes. You don't care. You don't care about the IP address of that machine. You don't care about how that needs to be routed to get there. So there's location transparency, right? That request just magically makes it to this destination, and you magically get a rendered website on your phone, right? Wherever you are. We can do the same in software. When we send a message, we don't need to know which component or where that component is to be able to get the message there. If all we need to do is just say, I have a question. Here's a query that describes my question. And then magically, it finds a destination that has the answer for you, and magically that answer makes it your way, and that's it. In that case, the business logic in these components doesn't care whether it's the blue component or the red component that needs to answer that question, and whether it's in a different component or a different deployed unit or in the same. Still alive? But there's something about events, though. There's something about events that is a little bit different than commands and queries. So because events describe something in the past, we can store them. We can put them in some Kafka topic if you want. And we can have this service just publish them there. And then that other service can read them whenever it wants. You can read them a day from now because they still describe facts. I mean, they don't unhappen. Right? So you can follow that stream at your own pace, which is really powerful. It is truly asynchronous communication. Right? That second definition is not completely wrong. It is very asynchronous communication, as long as you describe proper facts in those. And this process is what we call event streaming. But there's something really interesting with those events because they describe something in the past, but they're also quite detailed. Right? They tell you exactly what happened. So they tell you a story. And this is the story of somebody who bought wanted to buy 2 chairs, but actually bought one. They removed 1 chair, confirmed the order, then the order was shipped and it was canceled after it was shipped. Well, if you cancel an order after it was shipped, there's going to be a shipment at your door that you need to send back. And that's exactly what happened. That's your story. That is what we store in our database. Tells you a different story. Somebody bought a chair and sends it back. Okay, whatever. Not interesting, right? So there's 2 separate truths, right? There's one truth that we emitted as part of our events, and there's another truth that we store in our database. But the value is on the left. That story is much more valuable than the story on the right. Yet the one on the right is the one our application uses when making decisions and doing stuff. So here's a crazy idea. Why don't we throw it away? Why don't we just not use that and only use the valuable story? So instead of having that service use a database to store the current state of things, why don't we use the events that it emitted in the past for new decisions it needs to make? That would be a crazy idea, right?
Yeah.
But it has a name, so it's not crazy. It's established because it has a name. And that's called event sourcing. And a lot of people, when you read blog posts, very often confuse event sourcing and event streaming. Event sourcing is really about using the events you emitted in the past to make new decisions. So any decision of an event to publish was a result of reading or using the prior events. That doesn't come out right, never mind. I hope you get it. And we can combine that with event streaming. So the events that it produces, it doesn't have to use that only for itself. It might as well stream that to other services that maybe do something valuable with it. Maybe that component is good at answering questions. We'll see how we can do that a little bit later on. So if we want to use events as a source of truth, it is important to realize that we should not use events as a side effect, but really use events as the source. So imagine that this service here makes decisions based on its state in its database, right? Very common. And then it emits an event as it did something to an event bus, which notifies that other component, which in turn uses a database to make decisions based on the state, based on the event that comes in and does something. Now that database tells you a story. The messages flowing through that event bus will tell you a story. And that database will tell you a story. Do you know the game Telephone Game?
Mm-hmm.
It's fun, isn't it? Put a bunch of kids in a row, tell a story to the first kids, blah, 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 the last kid tells a story, and you laugh because it's nothing like the original story. And it's funny because kids do it. It is not so funny if your bank account is managed, or the funds on your bank account are managed through that telephone game. But when your banker plays telephone game, you don't laugh. But it's unfortunately reality, right? This is what works. And we did this talk at JP Morgan this afternoon, and they acknowledged it. That's us. Okay. It's not my bank, but my bank does it as well. So there's no point in it. There's no hiding, there's no. So what if we use event sourcing, that stream of events becomes the truth, the whole truth and nothing but the truth, right? Because we produce events when something happened, and it only really happened when I put it on that stream. Because something didn't happen if you don't change your behavior after that. And it only changes because now it's in that event stream, and when we read it, we read that event too, and that changes the behavior for the next event we're going to publish. So we only have one source of things. And everything that's in that stream was known for every decision that was underneath that. So you know exactly when that decision was made, those decisions were known already. So why would we want to do that? We pull that up soon. So there's a couple of business reasons why you would want to use event sourcing. And one of them is makes the decisions in your system very reliable, right? You know exactly what decisions, prior decisions or prior effects have been taken into account when making a decision. But which is very useful if you're in an environment that is audited or you have compliance requirements, or if you just simply want transparency of information. If you want to do data mining and analytics, you can imagine that, you know, the detailed story of that somebody putting two items in a basket and taking one out, maybe that's a behavioral pattern of people that are not sure whether they want the article or not. If you're not sure if you like something, you're not going to buy two of them. You'll try one first and then cancel your order before the shipment, or never mind, it doesn't make sense. So there's definitely some value that we can uncover later. And something that's really interesting as well is it makes system integration much more reliable, because everything is append only and messages don't just disappear. So when a system is not connected properly for a little while, as soon as it comes back, it can continue reading the stream where it left off. We don't have to figure out ways to do complicated queries to get the information that we may or may not have to synchronize, right? Those nightly batch jobs, forget about it. But there's also a bunch of technical reasons, and I'm not going to go through them all, but the last one I find particularly interesting because our brains work using events. Humans are event-based. Everything we do, we respond to things that happen as they happen, because I don't have a little piece of paper that has the current state of life. And I make my decisions looking at that piece of paper and just process events as they come. Yet when we build software, we translate that to state, and we use documents that describe what needs to happen, and we translate that, and everything is state-based that we do. And that complicates things quite a lot. And we've gotten used to that type of complexity. You'd be surprised to see how easy certain problems are to solve when you just reason about things that change. Things that happened in the past and things that need to happen now or not because of what happened in the past. So event sourcing is a really good way to tell you how you got to the point where you are. It's just not really good at telling you where you are. If you're in a shop and you want to know if you can buy that latest iPad, and you want to know what your account balance is, but the only thing you have is all the transactions in the past. It'll take you a little while to figure out whether or not you can buy it, right? It's adding, subtraction, adding, et cetera, et cetera. So you need a way to get the current balance, right? You want to know, okay, what's my balance right now? And this is where CQRS comes in. Who's not familiar with CQRS? So CQRS is command query responsibility separation, a mouthful. And the idea is very, very simple. You take your system and you just divide it in two. And one part of that system is responsible for dealing with the change. So any operation that changes the state of the system is on the left. You don't provide any information because that's the responsibility of the components on the right. They are designed to answer any questions that you may have about the system's current states. So the idea is to separate them because providing information is a completely different problem than making decisions on how to change, how to deal with a request for change. So we want to use different models for those. Right? We don't want to use a Chinese map for everything, and we don't want to use the Mercator projection, as the other one is called, for everything either. So we want to use different models for each of them. And very often you'll find CQRS combined with event sourcing. Why? Because they're really powerful together. They're not the same thing. They don't belong together like pepper and salt. Right? Very often you find them together. And you can use event sourcing for the command model. So every decision that is made with the knowledge of all the decisions that were made before that. And we can use event streaming to stream all of those decisions to the projections to make sure that your question about the current balance actually gives you the current balance every time, over and over again. And then very often the question arises, what about eventual consistency? What about I do a transaction and look at my balance and I see my old balance? Well, that's reality. That's what happens in your banking app, right? If you make a payment and you look at your app right away, you'll not see the payment in there, right? It's the reality of life. But we find it scary. When we build our own systems, it is, we get shivers, right? But it's normal in life. Everything in life is eventually consistent. But in software, somehow it's scary. And while we try to avoid it, we get the only thing that's worse.
Waiting.
Worse. Waiting is not that bad. Eventual inconsistency. We end up having systems that, well, we missed one message, we missed one update somewhere, but nobody notices. And then suddenly, systems, you'll see that, well, we all know that who has never gone into a database to just, in the production database to change a field because the behavior was wrong? I know why. I mean, it happens almost all of the time, right? And that's because there was an inconsistency somewhere and nobody knows really how it got there, but it got there and we can fix it, right? But a lot of those inconsistencies remain hidden as long as nobody complains. Right? And you don't want an auditor to find that inconsistency before you do, right? So again, if you're at the bank, be careful. And the solution to that is to be event-driven. Don't do event-driven as a nice hipster thingy on top of whatever you're doing, but be event-driven. It comes from within. It is a state of mind. I mean, how hard can it be, right? Well, there's a bunch of technical things that you need to care about, and if you don't, they start caring about you, and then your life becomes really miserable. These are the mosquitoes of any message-driven system. Fortunately, there's tools that can help us. Right? And some of those tools are, well, created by us, obviously. And this is what I'm going to use in the demo, given enough time. Until what time do I have?
8:30. Okay.
Okay. So there's Axon Framework and Axon Server, which I'm going to demo later. Axon Framework is well, you'll see the code. That's Axon Framework that help you implement these concepts of event sourcing and CQRS, and gives you all sorts of ways to zap the mosquitoes that try to attack you all the time, right? And Axon Server is a component that acts as an event store, so it's really good at storing events, which is typically an append-only kind of storage, but it has very specific read patterns that it's optimized to do as fast as it can. And it also takes care of routing messages. So it knows that events are pops up. Well, a lot of systems know that, but it also knows that commands are routed using consistent hashing, that queries need to be routed to the component that is fastest at providing the answer, et cetera, et cetera. And it follows a freemium model. It's commercial software, but it has a free version that you can use in production anywhere where you want. Because if you want the cool features, then it becomes paid. And the idea of that message server is that you could plot every solution that you have for messaging on a scale of how smart it is and how knowledgeable it is about the messages that it transports. And smart is not a good thing and dumb is not a bad thing, or the other way around. It's just different, right? It's a choice that you can make. So on the smart side, we have our enterprise service bus, right? It knows about the messages. It can do transformations. It can do routing based on those messages. It can do retries, lots of stuff. So what happens is you gather a bunch of people around those systems and they start maintaining that. And then everybody relies on those people and they become the bottleneck of the entire organization. So we don't like that. So what do? Dumb pipes and smart endpoints. We make the pipes really dumb. We make the teams really smart. And those message brokers, and this is where RabbitMQ and Kafka are. They don't know anything about the structure of a message. For Kafka, a message is just a bunch of bytes. And some application gives you the bytes. You put them in a topic. And when another application says, give me a message, it just gives you the bytes. It says, I don't know what it is, but this is it. Yours, good luck. Right? And it's very powerful because you can do all sorts of interesting things and it performs generally quite well because there's not much processing going on inside of these components. We feel that there is a middle ground, a little bit further to the left, actually in the middle. And this is, maybe it's because we're a Dutch company. I don't know if you know anything about Dutch politics, but we are really, really good at finding the middle ground that works equally bad for everyone. Right? It's not about advantages. It's that if you have a disadvantage, it is okay as long as the other party also has a disadvantage. For some reason, we still make progress, but I don't know how. It just accidentally happens, I guess. I always have a feeling that the government does what it does and then life just goes on. Anyway, probably the same here, I guess. But so what we feel is, and there's a bunch of buzzwords that marketing minutes do now. So there's actually a meaning to that. Zero configuration, meaning that it's fine to have these routing patterns, but they should not be configured in the messaging components, right? They should, well, in this case, they're predefined, like event, oh, that pops up. Is it a query? Oh, that's routed to the fastest endpoint. Is it a command? We use consistent hashing. And it's application driven because the applications tell the message component like, okay, this is the type of command I can handle. This is the type of query I can handle. So I am a possible destination for those types of messages. And that's where the stereotypes comes in. It only understands the stereotype of message. Is it a command? Is it an event? Is it a query? That's it. The payload is completely, it's bytes. Whatever payload you put on is the payload that the destination gets. There's nothing, no transformation going on whatsoever. Right, let's see if we can get it done.
New UI
Works. Is it legible?
Yes.
Maybe if we switch out the lights.
Yeah, try the light, yeah.
Is this one, that
I
one?
think the one farthest, I forget, I don't know.
No, that's better.
Okay, there you go. All right.
That was scary. Anyway, you never know when you switch off.
It could have done anything.
Sorry?
It could have done anything.
So this is a demo application. I'll show you the GitHub URL later on where you can play around with it yourself. But it's bike rental, right? Dutch bikes all over the place. Actually, rental is very non-Dutch, but we just own a couple. But yeah, when you rent a bike, there's of course the rental itself, but the whole purpose of that rental is that you get paid for it, and there's an external system that we simulate using the payment components. So it basically has two components: the actual rental application and a payment component that we simulate as an external component, right? That takes care of our payments. So let's look at the rental application, and it's a huge application. Probably have 6 classes in it. And there's a command side, there's the query side, there's a saga, which is basically a business transaction that takes more than one asset transaction. So there's a couple of things that needs to coordinate between components. And it basically takes care of, we'll look at the code in a second. It takes care of when you request the bike that you actually get the payment done before you can ride the bike. And when the payment completes, it unlocks the bike. Yeah. Virtually, not literally. And then there's a UI component that has our Spring web controller. So this application uses Spring Boot, and there's a lot of auto configuration. That's the last class there to just make it magically do what the product owner intended. So if we look at the bike, so the bike is in our command model, right? In that cloudy thing that I had, it's on the left side, the command cell. And it is a class that disappeared. So it's annotated. Thank you. It's annotated with @aggregate. That's a way to tell Spring Boot that it's an aggregate, and then there's an interesting tango going on between Spring Boot and Axon to make to configure things. And it has states. And these states are the things that we care about when making decisions. Because when we want to rent out a bike, we need to know whether it's available. If a bike is confirmed, we want to make sure it's being confirmed with the actual person that it was reserved for, and not somebody else. That would be a problem in the system. And if it's not available, but the reservation was not confirmed because it wasn't paid, etc., then we want to know that as well. And we want to know that because for example, in the command handler, so this is the way in Axon framework to say this method must be invoked when a command of type request bike command comes in. And when we do that, we want to check if the bike is actually available. If it's not available, we throw an exception. This is not really best practice to do it that way, but it's a demo, so you can get away with anything. And if it is available, then we can apply an event. And this is the typical event sourcing way to say, okay, now this happened. It didn't actually happen yet because it only really happened when the event is on the event bus, right? But we don't really care about that. So we say, okay, the bike is requested. Now, that is available flag needs to be somehow magically set to the right boolean, right? In this case, we don't have the state of a bike stored anywhere. We only have the past events. So what we do when we load a bike, we load an empty bike, or that's what the framework does, and it will call every event sourcing handler for every event that was stored or emitted previously by this particular bike. So when a bike is registered, it is available for rental. When it is returned, it is available for rental. When it is requested, what is it there? When it is requested, it is not available for rental. So we change that boolean along the way, and it just loads those events and very quickly changes all the booleans every time until we reach the end of the event stream. Now we're at current state, and we can append our own event after that. The framework takes care of that, and there's a way to prevent millions of events to be loaded to get to the current state. There's some snapshotting that you can do, and it takes a full line of coding to make that happen. So on the other side, on the query side, we have what we call a projection. And that projection is basically a class that is responsible for saying, okay, how do these things that happen, how do they affect the current state of the system that people may ask about? Right, so it's more focused on what questions do we have? Well, in this case, we need to know whether there's a bike in a specific area, right? Is there an available bike near me? Which is, funny enough, not one of the queries that we have here, but well, there's one which is find available. Right? There's one query that's find available, just a type. We don't really care about location, it only complicates demos, so we left that out. But this is a Spring Data repository, so you can do some fun stuff with queries using sentences. So find all bike type, find all by bike type and status. So we want to find the ones that are available of the type that was part of the actual query. Okay. But to be able to answer that question, we need to know what happened. Right, so we have a bunch of event handlers. Bike in use, bike requested, for example, says, okay, if a bike is requested, we find the bike. This is a way because it gives you an optional, and if we actually found one, then we want to BS's bike status, nothing else. Then it is requested by, which changes the state of the bike, and because we change the state, Hibernate knows that when I commit the transaction, I'll store the changes as well. And this is some magic to have these subscription queries going. So I want to send an update to components that were requesting live updates of either all bikes or the one that is being updated right now. So that's our projection. And then we have a Saga. And Saga basically makes sure that when, and I'm not going through all the details of what happens here, but when a bike is requested, I am going to prepare a payment. And when a payment is confirmed, I'm going to approve the request for the bike. And when there's a timeout, I should have implemented that, but I didn't. When there's a timeout, I should reject it, but yes. You can submit a PR, I'll show you where later. So I can run this application. I love open source. We get to say that. So let me start. Really happy that IntelliJ didn't decide to start indexing.
So this integrates with Spring?
Yeah.
Okay,
You don't have to use Spring Boot, but Spring Boot is really convenient, and
Yes.
it plays on that convenience with.
nice.
Let me see, where is my. So this is the Axon Server dashboard, and here you can see that the application is connected to Axon Server, and they tell Axon Server what kind of commands they can handle. So if you look at the rental monolith, you can see that there's a return bike, a register bike, a request bike, a reject bike, and approve request command. Those are the commands that are in that application. And there's also some queries that we can do: find all, find available, and find one. Not particularly astonishing. So let's go to my beautiful UI, which is this. And we can request all the bikes. See how beautifully that renders? And you can see there's no bikes. Of course, the system is empty. I just started it. And I deleted the event store before coming here. So I can issue a couple of bikes. So this is a request that will send 20 commands of create bike, I think, or register bike, whatever the name is, of that particular type. Right? So now I can get the bikes. Now we have this list of 20 bikes. And you can see that one is in Barcelona, one is in London, one is in Milan, another one Milan, Paris. As you can see, we take biking seriously. We're not talking about neighborhoods, but we talk about global transportation. Right? The world will travel by bike for everything. That's our mission. Yeah.
I know that Houston's not on there.
I
had a problem with China.
That would be a death.
90.
I think they all died trying. There's one left in New York.
Okay.
The last bike. All right, so we can now issue requests. That's where they are. I'm a lazy developer.
The best kind.
Yeah, that's what I heard. So I decided to become lazy as well. So I created an endpoint that goes through the entire cycle of renting a bike. So it does a query to find the available bikes, randomly selects a bike, tries to send a command to request it. That will give us a payment reference that we can use in the payment system to confirm the payment, which then raises an event to actually unlock the bike. Then we write it and we drop it off in a random city in the world. And we do that 30 times, 10 concurrently. Oh, there it is. So, and it reports on whether that process was successful or not. And as we can see, it is sometimes not successful. And this is not the demo gods trying to make me pay for it, but you can see that the error is bike is already rented. This is the error you get because of actual concurrency in life. Things happen, and that has to do with the fact that we are asking, what are the available bikes, and picking a random one. We're doing that on 20 bikes and 10 concurrent. So it's just a birthday problem, right? There's the birthday problem. What is the chance of two people sharing the same birthday? Of course, if you have more people, there's a bigger chance it happens. So this is what happens, right? Every now and then there's a bike that doesn't actually get rented, and I can just run some of these. And what I can do as well is, how much time do I have? Very quickly, I can run an extra application. And I'm in the dashboard. Oh, no, that one. I should see it popping up in the second. There you go. 2 inches of the monolith. I can actually see how commands are being routed. So you can see 50 commands were routed. The 50 return bike commands were routed to that monolith and 0 to the other. Of course, I just started it. So let's do some performance testing. Oh, there we go. And now you see, okay, it added, 15, yeah, 15 on that one, 12 on that one. So you can see it's kind of balanced, and this is because of consistent hashing. It's never perfectly balanced, but it's pretty accurate. So it automatically balances all these commands on the same, on the available nodes. And as you can see, the number of approved requests is the same as the number of return requests. And that is not a coincidence. That has to do with the way commands are routed to nodes. If two commands target the same, in this case, aggregate, so the same bike, they are routed to the same machine. So that on that machine, you can do local optimizations like caching of the state of that bike. So you don't have to load it every time something happens. Right, of course, our bikers are really fast. They bike within a few seconds from New York to Barcelona and back. So we want to cache the state of the bike. Obviously not. All right, but that's still monolith, right? And I had this beautiful picture of, oh, you start with a monolith and you can always move to microservices. So how long does it take to deploy microservices? 5 minutes?
It depends.
5 minutes should be plenty, right? So let's refactor our monolithic application into microservices. So of course I've prepared something. I'm going to move those classes to the rental command module, which
That's no.
so just microservices because we can. Your boss will love it.
Excellent.
No particular reason, just microservices. Looks good on resume.
Yeah. That's why you do it.
That's why.
Yeah. Why else would
It's called resume driven development. Come on, move. All right, rental query. And of course the UI as well, because we can. All right. So I've moved all these classes, all these packages are now empty. There's nothing left in the monolith. And now we have these ones. You can see by the blue that, there are changes. So those classes are not there. Great. Of course, the side effect is that we now have to run several applications, but nobody cares because it looks good in the resume. Yeah, I know it takes a long time to deploy, right? That's a nasty side effect. So the refactoring was under 5 minutes.
Hey, yeah.
So if somebody asks, how long does it take? It's always under 5 minutes.
And if we want to add Houston to the list, we can do that. real
That will
quick.
take several days.
To go.
I could do that, but it's hard to go to the list of cities that I can randomly select. All right, there we are. So there's a payment processor, didn't touch that. That's our supposedly external system. Now there's rental command, there's rental payment, there's rental query, and rental UI. All right, let's go to our beautiful UI and generate some more rentals. Here we go. Okay, there's another okay there. Same pattern, right? Nothing changed. That's pretty boring. Disappointing, right? We have all these microservices. That's the same thing.
That's the same.
What do we do? So we can look at the commands and we see that you have the rental command that has 25, the order is different now. 25, 30, 25. Okay. But we have microservices because they're now independently deployable and scalable, right? So we can take the rental command, where are you? There, and start another one. While we're at it, why one? Why not just a couple? Should be.
It's just memory.
There's plenty of it. It's free. Not my budget.
There you go.
Oh, wait, it is, but now I can run it and, well, same behavior, right? And they get balance between all those.
Very cool.
Doesn't matter. Really boring, the way we like it.
We like it more.
Boring is good.
Fan of boring.
So a little recap of what that looks like. So part of it, no, that's okay. So we had, initially we had this monolith. So we had the payment module and we don't really care what's inside, it's some magical stuff. We had our aggregate, which has a command interface, an API. We had the Saga that coordinated between this bike and that payment over there. We have the controller to accept our requests, and everything was deployed as a single module, right? And there's a bunch of commands, right? The controller, some commands. There it is. The Saga, which coordinates, would send commands to the bike to approve and prepare payments. We had events flowing between them, and we had a couple of queries as well. And then when I moved those components, basically the only thing I did was change the boundaries, put everyone in a little box, but the messaging never changed, right? These messages still flowed between the exact same components. This is the location transparency in action. It didn't matter at all. Oh yeah, that's the happy architect. Oh yeah, it's so much fun doing that. Anyway, but to really be event-driven, right, it takes a little bit more than whatever fancy technology that looks good on the resume, or even our own, or whatever random fancy technology you want. Right? To be truly event-driven takes a bit more than that. It takes Mr. Miyagi. Are you familiar with this?
Yes,
You are. Everybody is.
excellent, Excel.
Exactly. It's about the techniques that we need to do, the things that are seemingly completely irrelevant and boring and annoying. Why do I need to do this? Why do I need to wax a car? Why do I need to learn how to operate Kubernetes? Why, etc. CI/CD? Why? Come on. Well, you know, they're all part of it, and they're all part of karate or microservices, if you will. It's about certain practices that we need to teach ourselves, and maybe they feel weird and uncomfortable in the beginning, but eventually we'll find out why they're so useful. The good news is we do not need to wax cars to understand microservices, but there's maybe even worse, there's a book that you can read. You might volunteer for waxing the car. But there's also, and that's definitely more fun, event storming, which is a technique to discover domains. You okay?
It's like I've seen that around the house.
There's event storming is an interesting technique to discover things, and it uses events to start a discovery process. And then there's event modeling as well. Event modeling is really good if you know you're building a software system. Event storming is really good if you don't know whether you should build a software system to solve a particular problem. You can discover all sorts of problems, and apparently you can even organize your wedding with that. Of course, you want to use that, not that, because if you do your wedding in a computer system, I don't know, that would be.
Oh, you got bigger problems.
Yeah, exactly. So those are definitely interesting techniques that you can deploy, and of course you need to do those before actual coding and not after. But they're very interesting, and it's very interesting to see what happens with a group of humans when they're forced to interact using events on sticky notes. First of all, when you stand up, you have different interaction with people than when you sit down. So standing up, looking all at the same wall, doing things in past tense is strangely interesting to see how that happens. I've never had a disappointing event storming session ever. So these are some links if you want to try this on your own. That's the GitHub repository where the bike rental application is, and this is the place where you can get the Docker image for Axel Server. That's obviously the free version. Or better, you can try it together with us. We are organizing a workshop from 5 to 8 p.m. Food will be. But it's on February 23rd. We don't have the exact location yet. It'll be somewhere around this massive area called Houston. And here's a link that you can use to pre-register. So we'll let you know when and where exactly it is. If you're interested, you can use.
If you need some space, I think improving might be.
I just heard.
Yeah, no, I'm serious. No, they're very generous. Yeah, about helping community and helping, folks in the area, companies to grow. So yeah, it's the best.
Thanks a lot.
Yeah, I'd be happy to help coordinate that.
Great. Yeah, so if you're interested, and this is where we will do an actual event modeling session. Short, of course, it has to be fun, so we're not going into insane details. And then see how that works out when you actually build an application after that. And we'll have something running, and we can even go to microservices. So you can put it on your resume. Was that here as well?
Yes, here's, oh, yeah, yep, sure is.
I wasn't
yes.
sure.
So then I also just started up linked in the chat, but so yeah, so we have quite a number of sponsors that give great door prizes. We've got for raffle, we got Intelligent Ultimate 1-year subscription license that is up for grabs. We've got a couple different great refactoring tools. One is called Structure 101. It's they have plugins for IntelliJ and for Eclipse, and it provides you sort of a map of your code from a high level, and you can see, okay, well, maybe where are some of the tangles in your software, in your code base. And then also another tool called structure Sonar Graph provides very similar functionality as well. There's a 1-year subscription license available for that as well. And then Webicator, you get a training voucher for any class of your choice. And then Big Cat Subramaniam has his Agile Learner website. No, okay, more.
There's no longer supported.
No, okay, all right, good to know. And was there anything else? Okay, all right, but yeah, so try and win something. And Sarah, did you mention you had something as well, or was
Yeah, we just mentioned it,
Okay.
I think the workshop.
Okay, very good, excellent. Okay, cool, great. Well, yeah, so if you want to take a snap and fill out the survey, and you can try and win something. Thank you so very much, Allard. Really appreciate it. This is very, very, very fun presentation. This is good. And then next month, we'll have a presentation by the folks from Bellsoft who make with the Liberica JVM, I think. So looking to present probably virtually. We're talking about having in-person presentation, but they're leaning more towards virtual. They did give us a number of different topics that they could speak on. So I'll put together the event and make a survey so folks can pick basically. So it'll have the highest chance of the most folks getting what they're actually interested in. So I'll get that out there very soon, and then folks can vote, and we'll see what wins out. So that'll be February 22nd. So the day right before the Excellent IQ. No, it won't collide with your event. So
No excuses.
yeah. No collision, no event collisions. So yeah. All right. That is it. Thank you so very much, everybody, for coming. It's a pleasure seeing y'all. I'd love to get to know you a little bit. All right.
Yeah.
Thanks. Stop button here, just a second. There we go.